When we are describing terrestrial ecosystems, it's important not only to describe what's going on above ground in terms of the vegetation and the animals, but also what's going on below ground in the soil. When we are describing and taking samples out of the soil, there are essentially two approaches we can use, and we are going to demonstrate both of those to you. The first is to dig a hole called a soil pit, and out of the wall of that pit we first of all describe the layers that we see, and secondly we take samples for analysis in the lab. But that's a lot of work, and it also leaves a hole which we have to fill in afterwards. So the other approach we can use, once we understand generally what's going on in the soil, is to use this device which is called a soil auger. It's a kind of a drill, and we drill down into the soil and pick out a sample, and we'll show you how to use that later as well.
What's up, guys? This is the soil pit Bob was talking about, and this is how we describe a soil profile. So we will dig a meter into the ground to expose a surface of the soil pit that is in the direction of the light so that we can see what is going on here. The reason you do this is because the soil underneath the ecosystem will define how that ecosystem grows and what can grow there to an extent. So this whole length, as you can see here with the tape measure, is your soil profile. Then your profile is divided up into horizons of soil, which are defined by characteristics such as texture, color, maybe even smell. So what you will want to do first when you're trying to describe your soil profile is you want to clean up the face that you're sampling. And what you do is you just take a spade and you do manual labor, like you're building a wall. And as you do that, you can feel the texture change in the soil as you drop from one horizon to the other. So if I go from the top to about there, I can feel a change in the soil texture. So I'm going to check out now if that's a change in horizon. So if I look here at about 30 centimeters, there's also a color change. So now I know that this is my first horizon. And I will tell my assistant that this is an A horizon in our pit. And this is where all your biological activity occurs. And then below this, all your soil horizon starts increasing in clay content, because the clay falls from the top horizon to the bottom. So all your biology is going on in here, and then this is mostly like soil storage and underground processes that go on. So that's our first horizon.
A horizon 0 to 30 centimeters.
Yeah. Okay. So each time you describe a horizon, you want to get its width as well. All right? Then what you also want to get is samples that you can work on in the lab to get more data. But what you can do in the field is you can choose the color. Well, classify your soil based on its color. So what you'll do is you'll take out a piece of the soil. This isn't very professional, but and you'll take a Munsell color chart, which is standard all over the world. You put the lights behind you, you put the soil in your hand, and you look through these holes and try match the color. So I'm going to say this is 10YR5/1.
10YR5/1.
Yes, so that would be the color classification of our first horizon. And then with the samples that you do take from this horizon, you can do further lab work to get a lot of data. So now we move on. There, after the first horizon, there's a color change. It becomes a darker gray, and this goes on until about 65 centimeters. So our second horizon is a B1 horizon, which is in your practical manual, which you should read, and that is from 30 to 65 centimeters.
B1 300 to 650 millimeters.
Yeah, always write your soil profile should always be in millimeters. So then what we do is we go through the color again. I'm not going to do the whole thing because it's very hot. And this one is a bit darker, so we can say 10YR4-2.
10YR4-2
Yes.
for B1.
And then if we move on to our last horizon, that is 60 to about 600 millimeters to 800 millimeters. And in that horizon, it's a dark gray, but there's also mottling, which is little specks of different minerals. So here we have blue and orange mottling. So what I'll do when I describe the color is I'll look and I'll describe the whole soil color, and then I'll describe the mottling colors as well. So from this chart, I'll choose a blue and an orange and the soil color, and we'll put that into our profile, our horizon description. And then at the end of that, we have a soil profile with 3 horizons. We have all the data, and that is our soil profile description for one pit. So now that we have described our soil profile, we have to classify our soil. And the way soils are classified, it's kind of like genus and species when you look at any living thing on the planet Earth. But for soils, we use form and series. Now the form we can get in the field using this book here and our soil pit, but the series we'll have to use samples that we've taken from the soil pit in the lab and get more data, and then we can define the series. So for now, let's start with our A horizon, and there are 5 types of diagnostic topsoil horizons. There's organic, humic, vertic, melanic, and orthic. So we believe this one is orthic because there's nothing special going on here. It's a very bland, relatively topsoil. So then we move down to our next horizons, and at this bottom one, what did we say was there?
I think we said it was a yellow brown in color and it was apedal.
Yeah,
So now I'm going to look through the book and diagnose the form of the soil. So it was orthic top layer and a yellow brown apedal second layer, which makes this, we think, an Avalon according to the classification, which is on page 90. And I think if we turn here, we can agree that this looks pretty much like the soil profile we have in our pit.
yeah, if we look at the photo in the
Yeah.
book, we can see an orthic plain horizon for the topsoil, and then it gets darker and more mottled at the bottom, which kind of looks like what we have. So this is just quick field work to get your soils classified. The rest will have to be done in the lab. Okay guys, so now we're going to collect our undisturbed soil clod from our A horizon. I'm going to try to be professional here, but you want to get a broken out piece like this from your profile. Okay, so this is pretty good. Now I've got this, I want to be gentle with it.
And I'm just going to put some padding in so it doesn't break up when we're transporting it. And we'll take this back to the lab and coat it in wax so that we can do a series of tests on it later on.
So now we're going to take our representative sample of our A horizon. Our A horizon starts from the soil surface and goes down 30 centimeters. So we've driven the spade into the level at 30 centimeters so that it can catch all our samples. And what you want to do is you want to take from the top to the bottom so that you get a full slice of it so it's representative. So dig down here, make sure it all falls down. And you need at least 2 cups of this. So, you know, dig. Okay, I'm going to stop digging because it's actually fun.
Yep.
So now we have our sample. We're going to put it into this box and mix it up. Yeah, go bro, I believe in you.
Is that enough?
Yeah, let's dig.
Okay.
Okay, cool. So now we've got our soil all mixed up. Now we need at least 2 cups to take back to the lab. Make sure your stuff is labeled. Label everything you ever take in the field. And here we go. Yeah, that's good. So now we're going to do our finger test for our soil. And this is a test you can do in the field to give you the texture of your soil. So I'll just take a sample and some water and begin.
Okay. So while he's mixing that, the first thing he's going to try and do is he's going to try and make a ball, a coherent ball. Oh, yeah.
It's pretty good.
And it's a pretty, I think you can agree that's a ball.
That's a ball.
So we would, and it seems pretty fine as well. So we would classify that according to this flow chart. It forms a firm ball and it's, I would say, a fine sand.
Cool.
Because there aren't too many coarse grains, are there, Tiago?
It's pretty fine.
Okay.
What's the next step?
The next step would be to try and form a sausage from that.
So we have a ball. Now
Yeah.
I must make the sausage. And it's breaking up. Even if I take a little bit and squish it up. Oh wow, we have a sausage, man. And
Yeah.
now-
Well, if it's a sausage, it can be a loamy sand.
wow.
Yeah. And the next step is to try and bend it slightly.
Oh cool, so now I gotta make a circle out of the sausage And if it does this, it'll be clay. So here's my best attempt, guys. Doesn't work.
Doesn't work. So it's
Doesn't
not a
work.
clay.
So it's not a clay. What is it?
Yeah. Well, it's a loamy sand, I think we agreed.
There we go.
In order to study our landscape, we need to take soil samples from different parts of our transect. We cannot dig soil pits everywhere we take soil samples, so we're going to use this machine here, which is a soil auger, to take samples. We're here at the top of our transect to take our next sample, which we're going to take using the soil auger. So we're going to twist it into the ground and collect our sample and put it into a well-labeled bag so that we know where we took our sample from.